Hello everyone. In this video, I'll discuss different type of assignments in Verilog. In Verilog, we perform two type of assignments at high level, continuous assignments and procedural assignments. First, the continuous assignments. This type of assignment continuously evaluates the expression on right-hand side and assigns it to left-hand side signal. The signal on the left-hand side must be of wire type or wire-like similar data type. The right-hand side expressions are written using operators like Boolean, AND, OR, NOT, XOR, and conditional operator. From hardware synthesis perspective, this type of assignment is ideal for implementing combinational logic, where the input is continuously propagated to the output. Here are some examples. The right-hand side in these statements are evaluated and continuously assigned to the signal on the left-hand side. Now let's see how the first example statement is implemented in hardware. The statement assign out equals to A or B and with C or D is synthesized using combinational logic or an AND gate. The inputs are continuously driving the output, which behaves like a wire. Whenever the right-hand side expression evaluates to 1, the signal out becomes true, and when the right-hand side evaluates to 0, signal out is false. We see the same behavior using signal waveforms here. Now let's discuss what is a procedural assignment. Procedural assignments are used within procedural blocks like always, initial, task, and functions to assign values to variables. In Verilog, variables serve a similar purpose as in C language, where a variable stores a value. The reg data type in Verilog is used to represent a variable. Inside these procedural blocks, we can apply powerful constructs, for example, if then else case, or for loops to create more complex logic. These control flow structures allow us to implement intricate logic, making procedural assignments suitable for sequential circuits. In procedural assignments, a variable holds its value until a new assignment is made. Here is an example. In this example, if any signal in the sensitivity list changes, the if-else block is executed. The value from the right-hand side is assigned to signal out. The variable out retains its value until another change in the sensitivity list triggers a new assignment. Within a procedural block, there can be two types of assignment statements, blocking and non-blocking. These assignment statements provide control over the execution order within a procedural block. Blocking assignments. Blocking assignments, as the name suggests, literally block the execution of the next statement until the current one is fully executed. The right-hand side of the current statement is evaluated and immediately assigned to the left-hand side before moving on to next statement. In other words, blocking assignments inside a procedure are executed sequentially, one after another, ensuring each statement completes before the next one begins. And the control passes out of the block only after the last statement is executed. Blocking assignments in Verilog are denoted by an equal to symbol. Here is an example Verilog code of a procedural block with blocking assignments. In the code, we assign and then display the value of the variables. Let's understand what happens during the execution of the blocking statements in the always block. The variables var1, var2, and var3 are initially initialized to 0. The first blocking assignment sets var1 to 9, which is here, and then we display the value of the variables. Since the blocking assignments are executed in sequence, the first $display command shows the value of var1 equals to 9, while var2 and var3 are still 0. After the second assignment, var2 is assigned a value of 5, while var3 is still 0. Finally, after the third assignment statement, var3 is assigned a value of 8. At this point, all three variables have been assigned their respective values, and the final display statement shows var1 equals to 9, var2 5, and var3 8. This simulation output clearly shows that blocking assignments are executed sequentially. Now let's talk about non-blocking assignments. When a non-blocking assignment is made, the right-hand side is evaluated immediately, but the assignment to the left-hand side is deferred until the end of the current simulation time step. Or in simple word, until the entire procedural block is processed. Non-blocking assignments allow for parallelism as all the right-hand values are computed and then the left-hand values are updated simultaneously at the end of the procedural block. The order of the non-blocking assignments in the procedural block does not affect the final result. It is denoted by a less than equal to sign in Verilog. From hardware perspective, non-blocking assignments mimic real hardware behavior where multiple signals are updated simultaneously. These assignments are essential for synthesizing synchronous logic such as flip-flop and registers in design. Now let's look at an example code. In this example, we assign values to three variables, var1, var2, var3, similar to previous one. However, now we are using non-blocking assignment. If we look at the assignments over here, they have a less than equal to symbol, which is a non-blocking assignment happening here. When we display the value of var1, var2, var3 with non-blocking assignments, we observe a different result compared to blocking assignment. As explained earlier, in non-blocking assignment, the right-hand side of each statement is evaluated and scheduled for assignment to left-hand side only after the entire procedural block is processed. This means the right-hand side values were captured, but they weren't assigned to var1, var2, var3 until the end of the time step. And that's why when we display the value of var1, var2, var3 at time step 10, the values shown here are 0. It's interesting that if we print the same var1, var2, var3 in the next time step, the values are set because they were assigned at the end of the time step 10. Now let's put together a comparison for blocking and non-blocking assignments. Blocking assignments update variables immediately, while non-blocking assignments update variables only after the entire procedural block is processed. Assignment statements are processed in sequential manner, while non-blocking statements are processed in parallel. For blocking statement, the ordered execution mimics the inherent logic flow of combinational logic, and these are used to synthesize combinational logic in design. Non-blocking assignments are primarily used to synthesize synchronous logic, such as inside always block to model flip-flop behavior. In this slide, we show two sets of code differing only in the assignment type. On the left-hand side, the assignment type is blocking, while on the right side, we have a non-blocking assignment, where we take input D, assign it to Qt, and then Qt is assigned to Q. If we look at the synthesized hardware of these codes, we find that the blocking assignments synthesize to combinational logic, while the non-blocking assignment synthesized to a sequential flip-flop based design. So this was an overview of different Verilog assignment statements. I hope this helps you to understand different types of assignment statements and their respective synthesized designs in Verilog.